in this series of videos, we're going to be learning about balancing equations as well as explaining why we need to balance equations in the first place. But before that, we need to do a little bit of a review of what the word matter is. Remember that matter is anything that exists in the universe that has a measurable mass and that occupies three-dimensional space. Now, the important thing about understanding matter in chemistry is the understanding that new matter cannot be created, nor can existing matter be destroyed. Now, what this means from the perspective of chemistry, if we take a look at this chemical reaction here, this means that the total mass of the reactants, which in the case of this reaction are calcium chloride and sodium sulfate, the reactants are the chemicals on the left side of a chemical equation, must be equal, or rather must be identical to the total mass of all of the products within a chemical reaction. So this means that our reactants, calcium chloride and sodium sulfate, must be equal to the mass of calcium sulfate and sodium chloride, our products. And this brings us to our understanding of what it means for a reaction to be balanced. When a reaction is balanced, the mass of our reactants and the mass of our products are equal. And the foundation about why this must be true is what we call the law of conservation of matter, also known as the law of conservation of mass, because the amount of matter which we can measure by mass from the reactants to the products doesn't change. So what exactly do we need to do in order to balance a chemical reaction? Well, remember that balancing a chemical reaction means that we need to make the mass of our reactants and products equal, but since we can't tell how much each element weighs without looking at a periodic table, we can instead simplify this by counting the number of atoms of each element. So if we count the number of atoms in our reactants and compare it to the number of each atom in the products, and if we make them equal, that means that our equation has become balanced. But remember that we cannot violate the law of conservation of matter, which means we can't just add new atoms or take away old atoms, because matter cannot be created, nor can it be destroyed. So for that purpose, we need to use something that we call balancing coefficients. Remember that a coefficient is just a number that is put before a variable in mathematics, and what a balancing coefficient is used to do is used to change the number of reactants or products that we have. So we can take a fairly simple look at this example here of aluminum chloride. So here we can see that aluminum chloride breaks down into the ion aluminum 3+ and the ion chloride here. So in order to balance this, all we need to do is add balancing coefficients so that we have the same number of atoms on each side. So if we look at aluminum, we have one aluminum atom in the reactants and one aluminum atom in the products, so it looks like we're good there. Now with chloride here, we have one Cl- here and 3 in the reactants, which means we would need to add a balancing coefficient of 3 here. Now, we technically don't need to write anything for aluminum, but I'm going to put a 1 next to each of them so that it's more clear how many of each atom we have. Now, the other thing that we balanced unknowingly by looking at this reaction here is that we actually balanced the charge. So if we take a look, we can see that aluminum chloride has no charge because there's nothing written above here, but aluminum has a charge of +3 and chloride has a charge of -1, but we know that -1 times 3 is -3. So charge must also be balanced by making the positive and negative charges in each of the reactants and products equal once again. Now we can see aluminum chloride has a charge of 0, and aluminum 3 plus and 3 Cl minuses means positive 3 minus 3 is also equal to 0. So by balancing each of the atoms, in this case, we also balanced the charge, and generally this is going to be true. Now, if we go up here, let's take a look at a seemingly more complicated example, because we're not dealing with a compound that breaks down into separate ions. Let's see if we can balance this. If we look at calcium to start our first atom, we have 1 calcium in the reactants and 1 calcium in the products, so that looks good. Then with sodium, we have 2 sodium atoms in the reactants and only 1 in the products, so we can add a balancing coefficient of 2 here. And this actually fixes another problem that we have. If we take a look at chlorine, we have 2 chlorine atoms in the reactants, and because we added the balancing coefficient of 2, that also fixed our chlorine count here. And finally, if we look at the polyatomic ion sulfate, here we have 1 in the reactants and 1 in the products, so it looks like we're good. So let's go ahead and put balancing coefficients of 1 next to all of the others, and according to the law of conservation of mass, we're good. One final detail that we can observe in the overall balanced reaction is this subscript text that we see in the bottom right corner of each reactant and product. These are what we call the states of matter, which tells us whether our compounds, whether our reactants and products are solid. In the case of calcium sulfate, we see that this is solid. Liquid, we don't have any liquids here, but the best example of a liquid compound would be liquid water. Or gas, and again, none of these compounds exist as a gas here, which leaves the AQ. Now, we can see in the diagram that this reaction is actually taking place underwater because all of these ionic compounds are mixed in a solution, meaning that they're part of water. So AQ is a state of matter that actually means aqueous, meaning that the compound is dissolved in water. Now that you have a basic understanding of constructing chemical reactions and using balancing coefficients in order to make sure that the number of atoms in the reactants and products are identical, you can try these examples here. They start out fairly simply and get progressively more complicated. In the next video, we're going to go over several strategies that you can use in order to balance the more difficult types of chemical reactions.